Look up at the night sky. It feels calm, silent, infinite. But just a few hundred kilometers above your head, space is anything but empty. Earth is surrounded by a growing cloud of debris, millions of fragments of metal, fuel tanks, broken satellites, and shards from past collisions. Each one moving faster than a rifle bullet. At orbital velocity, objects travel at nearly 28,000 kilometers per hour. At that speed, even a paint chip can punch a crater into a spacecraft window. This is space debris, also known as orbital debris or space junk. And it's one of the fastest growing threats to humanity's future in space. The problem began in 1957 when the Soviet Union launched Sputnik 1, the first artificial satellite in history. It was a technological triumph. But it also marked the beginning of humanity leaving permanent traces in orbit. Since then, more than 6,000 rocket launches have placed tens of thousands of satellites into space. Some still function. Many do not. According to the European Space Agency, there are over 36,000 trackable objects larger than 10 centimeters in orbit. Between 1 and 10 centimeters? About 1 million. Smaller than that? More than 100 million fragments. Most are invisible to tracking systems. But they are not harmless. The International Space Station has had to perform dozens of collision avoidance maneuvers. Astronauts sometimes prepare for emergency evacuation, strapping themselves into spacecraft, ready to abandon the station if necessary. This isn't science fiction. It's routine risk management. Low Earth orbit, the region up to 2,000 kilometers above Earth, is becoming crowded. And crowded space is dangerous space. In 1978, a NASA scientist named Donald J. Kessler proposed a chilling possibility. He suggested that as the number of objects in orbit increases, the probability of collisions increases as well. And once collisions begin producing debris faster than debris falls back to Earth, a runaway chain reaction could occur. One satellite collides. It shatters into thousands of fragments. Those fragments collide with other satellites. Each new collision creates even more debris. This cascading effect is now known as the Kessler Syndrome. Imagine orbital space transformed into a minefield of high-speed shrapnel. In the worst-case scenario, entire orbital regions could become unusable for generations. No satellites. No GPS. No weather monitoring. No global communications. Modern civilization depends on satellites more than most people realize. GPS navigation guides airplanes and ships. Satellites monitor crops, forests, and climate systems. Financial markets rely on satellite timing signals. Television broadcasts, internet services, disaster monitoring, all orbiting above us. A severe debris cascade wouldn't just affect astronauts. It would affect life on Earth. Some scientists believe we are approaching a critical density in certain orbital altitudes. The risk is no longer theoretical. It's mathematical. On February 10, 2009, space changed forever. For the first time in history, two intact satellites collided in orbit. One of them was Iridium 33, an operational communications satellite. The impact happened at a relative speed of over 11 kilometers per second. That's more than 10 times faster than a rifle bullet. The collision instantly destroyed both spacecraft. Within seconds, thousands of fragments were created. More than 2,000 pieces large enough to track. And many thousands more too small to monitor. Each fragment became a new high-speed projectile. Each one capable of destroying another satellite. It was the first accidental collision between two functioning spacecraft. But it was a warning. A demonstration of how fragile orbital space had become. Since then, satellite operators regularly maneuver their spacecraft to avoid potential impacts. These maneuvers are called collision avoidance burns. Sometimes they happen with only hours of warning. Every year, the number of close approaches increases. Low Earth orbit is no longer an empty frontier. It is becoming a traffic system without traffic lights. At the same time, commercial space activity is accelerating rapidly. Private companies are deploying massive satellite constellations. The most well-known example is Starlink, operated by SpaceX. Thousands of satellites already orbit Earth as part of this global internet network. And tens of thousands more are planned. The goal is universal connectivity, faster communication, global coverage. It is a technological revolution. But it also means that orbital density is increasing at an unprecedented rate. More satellites mean more possible collisions. Even if each satellite has propulsion and tracking systems, not all objects in orbit are controllable. Dead satellites drift silently. Spent rocket stages slowly tumble. And small fragments cannot maneuver at all. Every new launch must now calculate not only where to go, but what to avoid. Space traffic management is emerging as a new global challenge. There is no single international authority controlling orbital lanes. Instead, coordination depends on data sharing, voluntary guidelines, and trust. And as access to space becomes cheaper, more nations and private companies are entering the domain. The barrier to space is lower than ever, which means the risk is higher than ever. Some experts warn that without stronger coordination, a major debris cascade event could still occur. Not because of malice, not because of war, but because of congestion, because of mathematics. Because in a crowded environment, accidents become inevitable. Space once symbolized freedom and exploration. Now it requires regulation, responsibility, and restraint. Because what happens in orbit does not stay in orbit. It affects communications, navigation, weather forecasting, emergency response, global finance. Modern civilization runs on infrastructure we cannot see. And that infrastructure is floating above us. The age of space is no longer just about reaching orbit. It's about protecting it. If we created the problem, can we fix it? Engineers around the world are developing solutions. Some propose satellites equipped with robotic arms to capture dead spacecraft. Others are testing giant nets that can trap debris. There are concepts involving harpoons, magnetic docking systems, and even lasers designed to gently push debris into lower orbits where it burns up in the atmosphere. One of the most ambitious projects is ClearSpace 1, supported by the European Space Agency. The mission aims to capture and safely deorbit a large piece of space debris. If successful, it would be the first active debris removal mission in history. But removing debris is expensive. And there is a legal complication. Who owns space junk? Under international space law, objects launched into space remain the property of the launching nation, even if they are non-functional. That means cleaning up debris often requires diplomatic agreements. Meanwhile, new satellites are being designed with end-of-life plans. Some carry propulsion systems to guide themselves back into the atmosphere. Others are placed in orbits that naturally decay over time. Prevention may be just as important as cleanup. Because once debris is created, it's incredibly difficult to remove. Space may look vast, but useful orbital regions are limited. And humanity is entering a new era of space activity, lunar missions, Mars ambitions, commercial space stations. If we don't manage Earth's orbit responsibly, we risk locking ourselves out of it. The irony is profound. Space exploration represents humanity at its most ambitious. It's most visionary. And yet, without careful stewardship, our own debris could become the barrier to further discovery. The future of space isn't just about rockets and astronauts. It's about responsibility, coordination, and long-term thinking. Because the environment above our planet is just as fragile as the one below. And the decisions we make today will determine whether future generations inherit a gateway to the stars, or a wall of debris. Space debris is invisible from the ground, but it surrounds us. And whether we protect Earth's orbit, or lose it, is a choice we are making right now.